Right, now we're going to use the graphical calculator to investigate quadratic functions, which are functions of the form f of x equals ax squared plus bx plus c. And we're asked in this example to investigate the quadratic functions y equals x squared minus 6x and y equals minus 3x squared minus 6x minus 6, and we want to do this in different parts. We're going to find the equation of the line of symmetry. It's one property of quadratics that they're symmetrical. We are going to find the coordinates for the max or min points. And we are going to find the value of the max or min for the function. So let's start off with investigating this one here. I'll write my answers in blue. Go over to our calculator, go to y equals, plug in the function x squared minus 6x and trace it, and there it is. Just shift my, just increase the y min to minus 15 so we can see the minimum point. Right, and now we see that it actually has a minimum. It has two roots and it has a minimum, and we know that hopefully automatically because the x squared coefficient is positive. Now the question is, through which point does the equation of the line of symmetry pass through? Well, it always goes through the function's maximum or minimum in this case. So if we find the minimum, we can then find the equation of the line of symmetry. And remember, the equation is written x equals. It's this line we want to find. How do we find the minimum of the function? Do you remember? Okay, it's second calc, and then minimum. Second calc, minimum. And we choose a left bound, a bit like with finding roots, left bound, and we want to go to the right of the minimum, so you have to go all the way around here, and then a guess anywhere in between those. Oh, I made a mistake there. To do it again, second calc, minimum, left bound, go to the left of the minimum, using the left cursor key, enter, right bound, that's better, go to the right of it, enter, and then enter again. And I've got minimum equals 2.0 9999985, which is, we have to approximate to 3. The calculator gives us only a not very exact value, so the exact value is actually 3. And we can answer part B if we just stop here, because in the window here it's given us the x and the y values, and that is just, we just have to put them in coordinate form. So the coordinates is the x value, which is 3, comma the y value, which is minus 9. And the value of the function, the smallest value of the function is the value of the y value at the minimum. So that would be f of minus 3, sorry, f of positive 3 equals minus 9. So we've answered all those part questions. And now we have to solve the second part. Let's use a different color. Let's take green. Let's go to y equals and clear our first function. And now we want to plug in this function here. Y equals negative 3x squared minus 6x minus 6. Trace it, and this also has a minimum, which it shouldn't. It should be a maximum. I've missed out the negative sign. Let's go back. Just insert a negative sign. Second, insert, and then put in a negative sign. Go back and trace it. It should just flip it upside down. And looks like this one actually has no roots. It never actually goes through the x-axis, but it still has a line of symmetry. It still has a maximum. So we have to find that the value of the x value of the maximum, and then that will be our x equals, will be our line of symmetry. So I go second calc again, but then I want to have maximum this time, because it has a maximum. I go to the left of the maximum, enter, and I go to the right of the maximum, and then enter, and then I guess, and then it gives me the x value of the minimum, x equals minus 1. That's my equation of line of symmetry. The coordinates for the maximum in this case are minus 1, minus 3, that point there, and the value of the function, the maximum value of the function can have is y equals negative 3. So when x equals minus 1, the maximum value of the function is negative 3. Don't be confused, because quadratic functions can have a negative value for the maximum. All other values are smaller, but the maximum value of the function is minus 3.